So, ladies and gentlemen, you are all welcome to today's video. So, today we are going to look at the separation techniques. We are going to look at this. First is chemistry for JAMB and post and post-UTME. So today we are going to look at the concept of separation techniques. Separation techniques. So generally, ladies and gentlemen, when we are saying separation techniques from our basic knowledge, we know that when we say separation techniques, it's like a simple way, it's the types of techniques. So one of the types of techniques that's used in the separation of a mixture. So whenever you have two or more substances that are physically combined together, you can separate them. And the process of separating two or more components from a mixture is what you call separation techniques. Assuming now, because if we are saying separation techniques, we cannot actually say, we cannot just go ahead and start with separation techniques. But we have to understand the concept of mixture. What is a mixture? A mixture is when you have two or more substances. It's when you have two or more substances that are physically combined together. So when two or more substances are physically combined together, that combination is called mixture. Like for example, so the key in defining mixture is the physical method. So generally, when you have two or more substances that are, when you have three or more substances that are physically combined together, we call that, or we define that as a mixture. And this mixture, we have two types of them, what we call homogeneous mixture and heterogeneous mixture. Between these two homogeneous and heterogeneous mixture. So when we say homogeneous mixture, it means it's a type of mixture in which when you mix the two substances or more together, you cannot distinguish them. It means that they will mix. You cannot identify the individual component of the mixture because they will give you the same face. Like, let me just give an example of homogeneous mixture. So that is why in many cases homogeneous mixture are found in terms or in the case of solution. In case of solution. Like for example, now if you have a solution containing, if you have a solution containing one in a solution, if you have a solution containing number one, salt, and two, water, which is the solvents, and then last we also have sugar. So when you have salt plus water plus sugar, when you mix them together, it will give you what we call solution. And in this solution, you cannot identify the component of it. It means that from that mixture, you cannot clearly see salts, you cannot clearly see sugars because they have all mixed together to give one single base. So in the case of homogeneous mixture is a type of mixture in which the component of that mixture cannot be seen with the naked eyes. You cannot see them with the naked eyes. That is in the case of homogeneous mixture. And in the case of heterogeneous mixture, it's a type of mixture in which the component of that mixture can be easily identified or can be easily seen with the naked eyes. And that is why in many cases, the heterogeneous mixture, in most cases, they are suspension. They are suspension. And of course, whenever it is suspension is when you have insoluble solutes plus your liquids. So when you have insoluble solute plus a liquids, you have suspension. So it means that in the case of heterogeneous mixture, the component of that mixture can be seen with the naked eyes. Example of that, if you now add chalk plus water. Chalk is insoluble solids. So when you have chalk plus water, it's very easy to identify the component of the chalk and the water. So these types of mixture is called heterogeneous mixture because all the components can easily be seen with the naked eyes. So what we are saying is that generally when you have two or more substances that are physically combined together, you can easily separate them. But in a case where you have a mixtures, in a situation where you have a mixtures that you can in a situation where you have two substances that are chemically combined together, it's very, very difficult to separate them. And that is where, remember from our basic knowledge, we know that chemical changes is a type of change in which the component of the mixtures cannot be separated. But in the case of physical change, it's a type of changes that can be reversible. That means that you can separate them. So the process that I use in separating the component of the mixture is called separation techniques. So that is what we are going to look at. And this separation techniques is exploits a lot of various physicochemical parameters. So there are some physicochemical parameters that are usually used in separation of the mixture. So we can use some of the parameters that we can use in the separation techniques. Some of these physicochemical parameters we have like solubility. We can exploit the solubility of the two or more substances. So based on that, you can separate them. And you can use number 3, the boiling points. You can also use, or you can exploit the use of the differences in boiling points to separate mixtures. So that is two. And the second, you can also use, apart from solubility, boiling point, you can also exploit melting. So we have solubility, we have boiling points, and we have melting point, and in some cases, molecular ones. You can also use sizes. So these are some of the physicochemical parameters that may be exploits based on the nature of the particles to separate the molecules. Like for example, although we are going to look at the different types of separation techniques and how we are going to exploit these various physicochemical parameters to separate mixtures. So now we are going to start with the first one, filtration. So now we are starting with filtration. So filtration is the first separation techniques that we are going to start with. What is filtration? Filtration is one of the separation techniques that is used in separating mixtures between a solvent and insoluble solids. A solvent and insoluble solids. So it means that the key in filtration, the first thing that need to come into your mind when we are talking about separation techniques is filtration. So in filtration, we are talking about insoluble solids and a solvent. So it's a type of separation techniques that used to separate insoluble solids from a solvent. The type of separation techniques that used to separate insoluble solids from a liquid using solvent. From a liquid using filter paper. Using filter paper. So we are using filter paper. So if you have a mixture that contains insoluble solids and a filter paper, so the best way to separate those kinds of mixture is filtration. Like for example, if you have chalk plus water, it will give us what they call chalk suspension. Give us what is called chalk suspension. So if you now have this chalk suspension, how are we going to separate the chalk from the water? So this is our mixture. So what we are going to do is we usually use a filter paper. A filter paper is something like this. And then you fold this. When you fold it, it will give you something like this. And then after you fold it, then you fold it again, then it will give you something like this. After it gives you something like that, then you open it, and you put it into a funnel. And after you put it into a funnel, then by then already you have your funnel attached to a red hot stand. You have your funnel attached to a red hot stand. You have your funnel attached to a red hot stand, something like this. And you have your filter paper here. And then you will now pour your suspension. So you're going to pour this. And then of course here you have another container. So the liquids will pass while the suspension, which is the insoluble solid, which is the chalk, will be remaining on the filter paper. So the chalk that remains on the filter paper is called residue. While the water that passes through the funnel or through the filter paper is called filtrates. So one of the applications of filtration is used in the treatment of pond water supply. So that is filtration, and it has so many applications. So the next types of separation techniques that we are going to look at is evaporation. So it's what I want to explain here. First, the physical-chemical parameters that exploits when separating molecules or when separating mixtures using filtration is solubility. So the solid is insoluble. So based on that insolubility, then using a simple filtration you can separate them. But in this case, we are going to use evaporation. So in the case of evaporation, is the types of separation techniques that used to separate a solvent and a soluble solid. Soluble solid, it means the solid that dissolves in a solvent. So that types of that type of mixture, of course, is the solution, because in the case of this, like for example, evaporation, we're talking about soluble solids from a liquid. So when you are separating soluble solid from a liquid, you are using filtration. So you are using evaporation. And of course, in this method of evaporation, usually heat is used. Heat is used. So if you have soluble solid, let's say, let me give an example of soluble solid here. Let's say we have sugar plus water. It will give us what we call sugar solution. We have sugar solution. So this sugar solution, you can use this method of evaporation to separate them. So initially you have sugar and you have water. And after you mix them, you have sugar solution. So evaporation is a process where a heat is used to separate the component of the mixture. So therefore, in this case, the solvent, which is the water, will be evaporated, and then the salt, which is sugar, will be left in the container. Therefore, by just using heat, when you have sugar solution, the sugar solution can be separated to give you a sugar, and then plus your solvent, which is water. So that's evaporation. So it's a method that uses heat to separate a solution, or to separate soluble solid from a liquid using heat. So after this, apart from evaporation, then the next types of separation techniques that we are going to look at is separatum funnel. So in the case of separatum funnel, is the types of separation techniques that are used to separate two immiscible liquids. Two immiscible liquids. So when you say two immiscible liquids, it means two liquids that cannot mix together. So if you have those kinds of liquid combination, so when you apply separatum funnel, you can easily separate them. And what are the examples of these two immiscible liquids? If you have kerosene and water cannot mix together. When you have kerosene and you put water, you realize that the water is usually found below, while the kerosene will be at the surface or at the top of the water. And the reason is because the water is more denser than the kerosene. So that is why they cannot mix. One is denser than the other. So as a result of that, you can just apply simple separation techniques, which is separatum funnel, and then now open up your separatum funnel. So once you open the separatum funnel, then the heavier liquid, which is water, will be separated, or will first be eluted. Then after that, then you now switch off your separatum funnel, and then you now follow it with the kerosene. So kerosene or petrol and water are two immiscible liquids. So that is why, for example, in the refinery, that is why if you study chemistry, you can work in the refinery. And one of the role that chemists play in refinery is like this kind of separation techniques. So if you have a situation where you have water inside petrol, so the best thing to do to separate the kerosene, you know that it's a problem to have petrol in water. So it happens a lot of times in the refinery. So that is why you can just simply apply separation techniques, which is filtration, which is separatum funnel, to separate the petrol from water using what we call separating funnel. Okay, so the next thing after separating funnel that we are going to look at is decantation. Decantation. What happens in the case of decantation? In a decantation, it's a process that used to separate denser substances from less denser substances. Like for example, if you now have water with let's say let's say you have water containing some moods inside it. So what you are going to do generally, when you have the water, you allow it to settle. So all the mood substances, because it's much more denser than the water, it will settle down. And then the water will be at the top. And after it settles down, then now you remove the water, and then you are now left with the much more denser substances, which is the mood. So this type of separation is based on the weights, the heavier, the density of the separating particles. So the one that is higher, denser, will settle down, while the less denser one will be at the top. Then you now pour out the water, and then you are now left with the wood. So this type of separation technique is called decantation. It's called decantation. Let's see, for example, this is your container, and inside this container you have water everywhere. Some moods like this. You have some moods, and this you have your water everywhere. So after you have these moves here, then you allow the water to settle down. You allow the water containing mood to settle down. And what will happen? Then at the end, the water will be at the top, which is the less denser. And then of course your mood will be settled down. It's much more denser. So after you have this, then you now decant the water, and you now left with the mood, which is the one that is heavier at the bottom. So that is decantation. So the next separation techniques that we are going to look at is simple distillation. Simple distillation. So a simple distillation is also another type of separation techniques that is used to separate two miscible liquids. So in this case, it's separating is like, for example, in separating funnel is separating liquids. Also, a simple distillation is also separating simple liquids. But it's separating liquids. So both separating funnel and simple distillation, they are the method that uses separating two liquids. But the difference between the liquid is that in the case of separating funnel, you are separating immiscible liquid. That is the liquid that are not mixed. But in the case of simple distillation, it's a type of separation that uses to separate two miscible liquids. That is the liquids that can mix together. So that is why in simple distillation is used to separate liquids that are miscible based on their differences in boiling point. So therefore, in a simple distillation, cooling and heating is used. Cooling and heating, cooling and heating is used. By using both cooling and heating. So we are talking about two miscible liquids. So what are the examples of miscible liquids that are used to be separated by simple distillation? So in this simple distillation, you can separate liquids like solid miscible liquids. So when we have water plus ethanol. So when you mix water and ethanol, they will give you the liquids that you cannot separate them. Also, you cannot clearly identify the component. You cannot separate which is which. So, because they can all mix together, because they are closer in terms of the density. So they mix together, and once they mix together, they will give you what they call a miscible liquid. So it's a liquid. So it means that if you have ethanol or alcohol and you add it with water, they will give you what they call miscible liquid. You cannot identify the component. And of course, ethanol has a boiling point of 78 degrees centigrade. Then ethanol have a boiling point of 78 degrees centigrade, and water have a boiling point of 100 degrees centigrade. So generally we have what we call simple distillation set-off. So in simple distillation set-off, there are, of course, here, after you mix them together, you are going to have your mixture. So this mixture will now be taken into the simple distillation set-off. And in that simple distillation set-off, of course, as I said, it exploits the use of heating and cooling. So this mixture will be put into what we call round bottom flask. And then you heat it from the bottom. So what will happen in the set-off, there is what they call a thermometer, which will be taking the reading of the temperature. So as you are heating, once the temperature reaches 78 degrees centigrade, so it means that this ethanol will be evaporated. So as it is evaporating, in the simple distillation, there is what we call a condenser. That is what we call condenser. So as this ethanol evaporates, it will now enter into this condenser. And this condenser will now cool the vapor of this ethanol. It will now cool the vapor of this ethanol. So once it cools, then it will now convert the gaseous form of this ethanol into a liquid, and then it will now be diluted and passed into a beaker or conical flask, and then you have that. Then you continue heating it. As you have the thermometer will be taking the reading. Then water also at the same time, it will also evaporate when it reaches 100 degrees centigrade, and it will also enter the condenser. And the condenser will now condense it. After it condenses it, then it's now diluted into another separate beaker or conical flask. And then you now have the two separate mixtures. So it means that in the simple distillation, you are exploiting the differences in boiling point, the differences in boiling points of the two liquids to separate them. So that is what happened in simple distillation. And then the next thing that we are going to look at is fractional distillation. which is another type of separation techniques. So fractional distillation is a type of separation technique that is mostly used in refinery and oil industries. So this simple distillation is usually used in separating a complex mixture of liquid based on the differences on their boiling point. A complex mixtures of liquids. So it is a complex mixtures of liquids. So that is why this fractional distillation is mostly used to separate crude oil. Because in crude oil contains lots of different liquid in it, but with different boiling points. So that is why in fractional distillation, as you have your crude oil, you will be heating it, and as the temperature of a particular liquid, or as the temperature of a particular component is reached, then it will be evaporated. So it will be doing that one after the other. Like for example, in crude oil, we have petrol, we have kerosene, we have petroleum jelly, we have number 4, we have bitumen, we have diesel. So we have so many other components. There are so many things inside crude oil. So therefore, this fractional distillation will be used to separate these different components of the crude oil based on their differences in boiling point. So they have different boiling points. So based on that, the crude oil will be heated, and as a boiling point of a particular component is reached, then it will now be evaporated, cool, and separated into a separate container. Then the next thing may be kerosene, evaporate, cool, and separate. Petroleum jelly, bitumen. Visualize how it continues. So fractional distillation is used to separate a complex mixture that contains so many other liquids in it based on their boiling point. So that is simple distillation and fractional distillation. So the next thing is magnetic separation. So the next thing is magnetic separation. So in the case of magnetic separation, the types of separation techniques that used to separate magnetic material from non-magnetic material. It's used to separate magnetic material from non-magnetic material. Assuming now you have a mixture, maybe you have ion fillings inside maybe a sand. You have ion fillings and sand. So now you want to separate the ion fillings from the sand. What are you going to do? You get a magnet. And that magnet, you use it to start picking all the magnetic material, which is the ion fillings. So the magnet will pick all the ion fillings and left the sand. So this type of separation is called magnetic separation, as you are using magnet to pick off all the magnetic material and you now let the sand separately. So that is in the case of magnetic separation. And then the next thing after magnetic separation is centrifugation. So centrifugation is another type of separation techniques. Centrifugation is another type of separation technique. Centrifugation. So this centrifugation is actually used in separating molecules or mixtures based on their centripetal force. Based on their centripetal force, as you have the mixture, it will be rotated. It will be rotated, like for example, so in the case of centrifugation is when you have a concentrated particles inside a liquid. Like for example, if you take blood, in the blood there are so many components in the blood. So that is why centrifugation, and to separate those components, like for example in the blood we have what we call plasma and cells. So assuming that you want to get the plasma from the blood, you have to apply this centrifugation method. And it's based on the gravity, the shape, the density, and the sizes, and the rotor split. So as you now have your concentrated particles inside a liquid, you rotate it. That is in the case of centrifugation. So based on the centripetal force, the heavier molecules will be settled down, or the heavier components of the mixture will settle down. So once they are settled down, and different components may be settled at different speeds. The heavier the molecules, and the faster it is to settle down. So that is centrifugation. So it separates particles from a liquid or from a concentrated liquid based on their shape, gravity, rotor speeds, and their shape. And it's based on the rotation. It's like we have what we call centrifuge machine. It's a machine that usually rotates. So as it rotates, so many particles will be settled down, and as they are settled down, you can easily separate them, and that is centrifugation. So example, that is why we usually use this in hospitals. We usually use centrifugation machine at hospitals in doing or in carrying out some blood analysis. Carrying out some blood analysis, because from the blood, when you centrifuge, different components will be settled down, and you can just easily detect what you want to detect from the blood. So that is centrifugation. And the next one after centrifugation is crystallization. Yes, crystallization. It's crystallization. So in the case of crystallization, it's used to separate liquids. It's used to separate soluble solids from a liquid using heat. It's like evaporation. So therefore, in crystallization, we separate soluble solid from a liquid, and the solid, they are usually crystal. So once you heat, the crystal will be left and the liquid will be evaporated. Because generally in crystallization, when you have a solution, so some of the solutions tend to form what you call saturated solution, and the solids there will form what you call a crystal. So to separate the solids from a liquid, you apply this method of crystallization, as is usually using heat. So that is crystallization. And then the last one that we are going to look at is simple distillation. It's simple distillation. So it's simple chromatography. Chromatography. So this chromatography is used to separate pigments or dyes, that is color. Used to separate pigments slash dyes. When we say pigments or dyes, it means color substances. So chromatography can be used to separate pigment or dyes based on their differences in solubility. Based on their differences on solubilities. So that is chromatography. And ladies and gentlemen, this is just a short introduction of separation techniques. And in the next video, we are going to look at some problem or some questions that are associated with these separation techniques. Thank you. And if this is the first time you are coming to my YouTube channel, please subscribe.